Your place in the universe is far more complicated than you might think. Most people see their address as a street name, city, or country. We rarely consider our cosmic address, and yet the universe is anything but simple. We once believed our horizons ended at Earth's atmosphere. Yet over time, telescopes and satellites peeled back layer upon layer of the unknown. Astronomers made startling revelations that stretched our concept of home across interplanetary distances, and then well into the realm of galaxies and galaxy clusters. What if I told you that your cosmic address doesn't stop at the Milky Way, or even at the enormous supercluster called Laniakea? Each new discovery uncovers unexpected scales of distance and size, hinting that our home universe is part of something vaster. From ancient stargazers who mapped constellations in the night sky to modern scientists tracking galaxy flows with advanced telescopes, humanity has always chased the question: just how big is our true neighborhood? In the next few minutes, prepare to travel step by step from Earth to the edge of known cosmic structures. We'll start with what we see outside our windows, a tiny blue world orbiting a star called the Sun. Then we'll leap beyond our solar system, zoom out to our galaxy, and finally plunge into the biggest superclusters found so far. By the end, your sense of place might feel both humbling and electrifying. You'll see that discovering our cosmic address is an ongoing journey, and scientists are just beginning to map the biggest features of our universe. But let's not get ahead of ourselves. First, we begin right here, at ground level, imagining our planet's place in the immediate cosmic backyard, because everything that follows builds on the breathtaking reality that Earth is but a speck in an ocean of stars. Look up on a clear night, and you'll see countless points of light scattered across the dark sky. That faint glow is your first clue to how vast space is. Earth itself is an impressively complex biosphere teeming with life, but once you compare it to the scale of the Sun, it shrinks to near invincibility. Imagine the Sun as a bright basketball set down on a field. On that scale, our precious planet is a pea orbiting around 23 meters away. That's close enough for you to walk within a few steps, yet the difference in their size is beyond stark. Travel outward to Pluto, and you'd find something as small as a grain of sand, stationed over a kilometer from your basketball-sized Sun. Already, that distance feels immense, and yet our entire solar system is only a tiny fraction of a bright swirl of stars we call the Milky Way. Earth is one planet among 8 recognized major planets and a host of dwarf planets that revolve around a star so large that over 1 million Earths could fit inside it. Yet the distances and sizes of our solar system alone can boggle the mind. Still, it's just a single star system among hundreds of billions in the Milky Way. Astronomers often mention that if you try to reduce the solar system to a scale you can hold in your hand, you lose track of just how far away objects like Pluto truly are. If you scale the solar system up, you lose sight of Earth in the glare of the Sun's mass. One moment we're an important planet, the next we're smaller than the dust when viewed against the cosmic canvas. We might see ourselves as the center of everything, but the truth is far more humbling. The solar system with all its planets and moon systems could disappear in the background of the galaxy, and nobody would notice from even a modest distance away. As we'll see, zooming out to the Milky Way's full breadth renders our entire solar system invisible. This is just the beginning of the grand tour that reveals we don't merely live in a solar system. We occupy one cell in a cosmic swarm of countless solar systems. So let's move outward. We've left the Sun and its orbiting bodies far behind. Now it's time to see what kind of neighborhood our star actually calls home. Sweep your gaze across a clear, dark sky and you'll notice a hazy band of lights arcing overhead. That cloudy swath is our vantage point on the Milky Way galaxy, a colossal spiral with arms stretching tens of thousands of light years from its central core. Within those arms lies hundreds of billions of stars. Our Sun, that enormous ball of plasma we revolve around, is just one such star in a sea of cosmic brilliance. Scientists have measured our galactic diameter and concluded it's roughly 100,000 light years wide. though the exact figure is under continuous debate and refinement. To put that in simpler terms, a light year is the distance light traveled in 1 year, about 9.46 trillion kilometers. Multiply that by 100,000, and you realize how quickly words like enormous fail to capture the mind-bending scope. Our solar system sits in a region called the Orion Arm, sometimes referred to as the Orion Cygnus Arm. This location is nowhere near the bustling center of the Milky Way, which is packed with stars and swirling clouds of interstellar dust around a supermassive black hole known as Sagittarius A. We're positioned in the suburbs, in a calmer stretch of space with fewer close stellar neighbors. Though we can identify major spiral arms and name certain star clusters, the galaxy remains mostly unmapped by direct observation, because we're trapped inside it, trying to see across dense layers of dust and gas. Yet data from instruments like the Gaia spacecraft have yielded the most precise star maps we've ever had, revealing the shape of the Milky Way in greater detail. Even so, if you zoom out just a little more, our entire solar system becomes so minuscule that it blinks out of sight. For perspective, if our solar system was the size of a quarter, the Milky Way could extend around Earth's circumference dozens of times. That's an immense structure, hosting star nurseries, supernova remnants, and perhaps countless planets capable of supporting life. Still, for all its grandeur, our galaxy isn't drifting through space all alone. The cosmos is filled with neighbors, some near and some impossibly far, and we share a broader community known to astronomers as the local group. The Milky Way has siblings, cousins, and distant relatives in a gathering of galaxies astronomers call the local group. More than 50 galaxies cluster here, drawn together by the invisible hand of gravity. Some are large spirals like our own Milky Way or Andromeda, M31, which itself boasts a collection of star systems that could rival ours. Others are smaller satellites, often called dwarf galaxies, that orbit these large structures. For a long time, Andromeda has been the nearest giant spiral galaxy to our own. It sits approximately 2.5 million light-years away, so distant that if you attempted to travel there at the speed of our fastest aircraft, you'd never complete the journey in any normal human timescale. Andromeda fascinates astronomers because it's on a collision course with our galaxy, predicted to merge in about 4.5 billion years. That might sound terrifying, yet galaxies collide and merge routinely in cosmic history. They pass through each other like phantom giants, each star so distant from its neighbors that direct collisions of stars are relatively rare, although gravitational perturbations can reshape entire galactic arms. Beyond the Milky Way and Andromeda, though, the local group is peppered with dwarfs like the large and small Magellanic Clouds, both visible in the southern hemisphere sky. They're minor galaxies orbiting the Milky Way, and each is loaded with younger, brighter stars. There are many more dwarfs out there, some discovered only recently. Telescopes keep spotting faint, irregular galaxies lurking in the darkness, adding to the tally. You might think these 50-odd galaxies represent a large cosmic address, but our local group is still just a node in an even bigger structure. In fact, the countless clusters of galaxies that fill the universe typically form networks, sometimes called the cosmic web. By looking at how these clusters connect, astronomers realize we live in a neighborhood far more immense than anyone had ever imagined. A giant supercluster called Laniakea. In 2014, a research team led by astronomers like R. Brent Tully unveiled something that sent shockwaves throughout the scientific community. They found that the local group of galaxies, including the Milky Way, belongs to a supercluster they named Laniakea, which in Hawaiian means immeasurable heaven. The name perfectly captures its colossal scale. It spans about 520 million light-years and includes roughly 100,000 galaxies, each galaxy containing billions to trillions of stars. Before this discovery, scientists had identified local superclusters, including the Virgo supercluster, which the Milky Way is a part of. However, they didn't grasp the entire gravitational landscape that forms the single, cohesive unit called Laniakea. Think of it this way. Each galaxy can move individually, but large-scale flows of galaxy act like water draining toward a basin, revealing deeper gravitational connections. The Laniakea region is such a basin, thousands of galaxies streaming, slowly yet surely toward a spot known as the Great Attractor. The Great Attractor is an immense gravitational anomaly that draws in galaxies from all directions. If you picture galaxies as leaves floating in a pond, the Great Attractor is like the vortex pulling them forward. While the Great Attractor might sound like something out of science fiction, it's a real phenomenon so massive that it influences the motion of everything in our corner of the galaxy. The entire Laniakea Supercluster is effectively drifting along, guided by this gravitational force. All of this was part of a game-changing insight. The universe has structure at truly enormous scales, with filaments, sheets, and voids stretching across hundreds of millions of light years. Just when science began celebrating the creation of a new cosmic map that finally captured our place in all of this, further observation suggested even more staggering structures beyond Laniakea. So, we still hadn't reached the final boundary of our address. Although we once thought that Laniakea might be the final word on our cosmic neighborhood, a mysterious region of space known as the Shapley Concentration changed everything. Back in the 1930s, astronomer Harlow Shapley observed what he described as a significant cloud in the constellation Centaurus. In those days, equipment was limited. He couldn't fully unravel its secrets. He knew something was there, a cluster of galaxies or some large assembly of matter, but the details stayed out of reach. Modern telescopes and advanced sky surveys such as the Cosmic Flows Project have now peeled back the cosmic curtain. They revealed that this cloud is actually an immense supercluster of galaxy, possibly the largest known gravitational anchor in our section of space. This region dwarfs even Laniakea, so much that our entire supercluster seems to be drifting in that direction, like travelers heading down a cosmic highway. Picture Laniakea already mind-boggling in size. Now realize it's just one piece of an even bigger puzzle. The Shapley Concentration comprises multiple superclusters, huge chains of galaxy that converge into one gravitational well. Astronomers suspect this region is so massive that it helps shape local cosmic flows at scales once thought impossible. Our entire Milky Way is just one participant in this migration, overshadowed by the raw pulling power of Shapley's titanic mass. Discoveries like this point to the importance of dark matter, an invisible substance that permeates the cosmos, making up the majority of matter in the universe. By tracking how galaxies move towards Shapley, scientists gain clues about how dark matter spreads through space. The galaxies are like drifting boats on a sea, and the gravitational currents can reveal hidden topography. This unexpected revelation about Shapley shows that Laniakea is not the upper limit of cosmic geography. If anything, it's an intermediate step in a vast hierarchy of structures. Every time we think we found the ultimate cosmic boundary, a new discovery extends that boundary again. The Shapley Concentration stands as a testament to how colossal these structures can get. But even that, it turns out, might not be the largest arrangement of galaxies the universe has in store for us. If Shapley upended our cosmic sense of scale, then the Hercules, Borealis Great Wall shatters it entirely. Discovered through gamma-ray bursts and large-scale galaxy surveys, this colossal formation is often cited as one of the largest known structures in the observable universe. Estimates suggest it spans about 10 billion light-years across. That's so enormous that standard analogies fail to convey its size. By comparison, the Shapley Concentration might stretch across only 1.4 billion light-years, which is still mind-blowingly huge. Yet the Hercules Borealis Great Wall dwarfs even that. It's essentially a giant filament of galaxies weaving through space, one that might defy some cosmological principles, such as the idea that at truly large scales, the universe should appear roughly uniform, the cosmological principle. These massive supercluster complexes imply that the universe's largest structures may be more uneven than once thought. Some astronomers question whether these extreme structures challenge our standard model of cosmology, which relies on dark matter, dark energy, and the Big Bang to explain how matter clumps together. Others point out that the Great Wall might still be part of a broader pattern hidden beyond the observable limits. Regardless, the mere existence of such an unfathomable thread of galaxies is a testament to how little we truly know. Each new observation forces us to rewrite our cosmic maps, adjusting the edges of the known universe to include more territory. The presence of something so large also raises questions about how matter organized itself so quickly after the Big Bang. Scientists estimate the universe is about 13.8 billion years old, and for galaxies to form such an extensive arrangement hints at the subtle interplay of gravity, initial density fluctuations, and dark matter scaffolding. The Hercules Borealis Great Wall reminds us that no matter how advanced our technology gets, the universe may always hold an even bigger surprise just beyond our line of sight. Reflect on the journey we've taken. We've started from Earth, that minuscule blue dot that orbits a star the size of a basketball on a model scale. Wandered through our solar system's lonely reaches, then discovered that even our entire system vanishes when seen from the vantage point of the Milky Way's vast spiral arms. We learned that our galaxy has friends, over 50 members in the local group, and that we're cruising toward a rendezvous with Andromeda. From there, we jumped to the staggering reality of Laniakea, a supercluster of 100,000 galaxies, only to discover that the Shapley Concentration overshadows Laniakea like a bustling metropolis overshadowing a small town. Finally, the Hercules Borealis Great Wall pushed the boundaries of cosmic architecture to almost unimaginable scales, showing that even Shapley is but one part of a far grander tapestry. The mind reels at these scales. Distance and size stop making intuitive sense. Even the speed of light seems slow in the face of billions of light years. Every new discovery feels like a reminder that we've only begun mapping the entire cosmic web. Dark matter, invisible to direct detection, sculpts the stage upon which galaxies perform their gravitational dance, guiding massive structures into being. With each refined telescope and each new survey, we find that our cosmic address extends beyond any previous concept of edges. It's like stumbling on a hidden city, only to discover that that city is just one district of a megacity that itself sits in a continent-sized region. Where does it end? We don't know. As scientists develop more sensitive instruments and gather more data, we suspect more colossal structures lurk at the edge of our observable universe, or perhaps entirely beyond it. Some researchers have proposed that phenomena like dark energy and cosmic inflation hint at an even grander cosmic stage. Ultimately, your cosmic address might read like a long chain: Earth, Solar System, Milky Way, Local Group, Laniakea, Shapley Concentration, and so on, potentially culminating in structures too vast to fit into any standard model. Take a moment to imagine yourself as part of this cosmic web. Right now, your life plays out in a city on Earth, a planet you might travel across in hours by plane, yet you're also a resident of a galaxy swirling with hundreds of billions of stars. You share this galaxy with neighboring galaxies that, together, form a supercluster in a cosmic rush hour, flowing toward enormous gravitational beacons. The more we look, the more that home expands to cosmic roads and highways, forming a map so large, it nearly defies comprehension. The next time you gaze at the night sky, remember that you're not just staring at pinpoints of light. You're glimpsing a grand cosmic tapestry, one that repeatedly defies our assumptions about size and boundaries. Our true address never stays put, because with every discovery it grows. And who knows, tomorrow's breakthroughs might reveal that even the Hercules Borealis Great Wall is just another stepping stone to an address we haven't finished writing yet. That's the real wonder. Our universe, by all accounts, might just keep on going, showing us that every time we think we've reached the end, we've only really scratched the surface of this infinite frontier.